Good afternoon, everyone.
Good afternoon, ma'am.
Now onwards, every day we are going to take a lecture on from home itself. Okay. So maybe due to range problem and all, some problem may occur. So you should cooperate with us. And if you are getting any type of a problem, you can message me. If suppose I have left out the meeting and all, so please cooperate because we are not allowed to go to university now.
Yes, ma'am.
Now, what we are discussing about, we are solving differential equation with the help of numerical methods, right? So in that, the first one which we have seen is by Euler's method, and the next we have seen is what was a change in Euler's and Euler's modified method. In the Euler's method, whatever the value of f of xy, we have substituted this as a sum function f of x naught y naught, right? F of xy, its value we have substituted as some constant f of x naught y naught, right? And in the Euler's modified method, we have used our from Taylor series for trapezoidal rule, in which we have the value is f of x naught y naught plus f of x1 y1 uh, in h by 2 in this bracket. Okay, the value of that integration of f of xy we have written like this. Okay, this was a change in Euler's and Euler's modified method. Now let us go for the next method, that is before that, I want to ask, is there any doubt for Euler's and Euler's modified method and the examples? Yes, if you are having any doubt related to example, related to theory, you can ask. Otherwise, we'll go for the next method. Hello, is there any
Yes,
doubt
ma'am.
related to last?
No, ma'am.
बाकीचे झोपतायत का? You should ask. Okay, let us go for the next. That is solution by Taylor series. Okay, in that also we are provided with one differential equation y dash is equals to f of x, right? Okay, what is y dash? It is nothing but your dy by dx. Dy by dx is equals to y dash is equal to f of x, y. Whatever y dash we have, it is nothing but your function. That is what our given differential equation with some initial condition is y of x naught is equals to y naught. Okay, this is what our initial condition provided to us. Now we have to find out the solution of this differential equation. Okay, for finding this solution of differential equation, let us assume that what we will assume, let y of x be the exact solution of our equation. Exact solution of equation 1. Okay, let y of x be the exact solution of our given equation 1. Okay, now if y of x is an exact solution, then we can write the Taylor series for y of x as y of x is equal to, I can write this in the form of y of x naught. We since our initial values given to us, that is y of x naught is equal to some y naught is given, that is from equation 2. So we can write this as in the form of Taylor series as y of x naught plus x minus x naught y dash of x naught plus x minus x naught square divided by 2 factorial y double dash of x naught and so on. So this is what say our Taylor series, which is we have written in terms of x naught, because since x naught is initial provided to us. Okay. Now what we need to find out here is x naught given to us. So simply y of x naught is also given to us. So what we need to find out is from this equation, we need to find out the values of y naught of x, right? Y naught of x, its derivative, first derivative, second derivative, y naught triple dash, and so on. Correct? Because this value is given to us. Y naught of x is given to us. X minus x naught is also given to us. X is any variable. So we need to find out the derivatives. Okay, y dash, y double dash, and all. But their values we have to find out at a point x naught. Correct? So if you are able to find out all these, then we can put it on our equation and we can solve it. Okay, are you getting? So this we can name it as equation 3. Now, if we are knowing the values of those derivative, y naught dash, y naught double dash, y naught triple dash and all, then after finding all these, we can put it in our equation so that we can get the solution. Okay, so for that what we need is, actually we are provided with y dash is equal to, what is the value of y dash we have? It is f of xy, right? Now let us find out what is y double dash from this itself. Okay, now here we are discussing for in general, because since we are not knowing what is a function f of xy. If you know a function f of xy, then we can find out y double dash with the help of that. Suppose f of xy is given to us as simply x square. So what will be y double dash? It is 2x, right? But now in this case, if we are not given with what is your y dash, so let us find out y double dash with the help of our usual method. That means by using a partial derivative. Since why we are using partial derivative? Since f is a function of two independent variables. Okay. So what will be y double dash? It is f dash of xy. Now how to find out f dash of xy? It will be nothing but f with respect to x dx with respect to x plus derivative of f with respect to y and dy by dx. Okay, so it is written as, so dx by dx, it will be 1, derivative of f with respect to x, I can write it as fx, plus derivative of f with respect to y, I can write fy, and this y dash as it is. This y dash is nothing but your function f. Okay, from this equation. So we can write this as fx plus fy into f is nothing but your y double dash. So this is what small a and b. Since we need to find out all the derivatives, y dash, y double dash, y triple dash, and so on. Correct? Are you getting?
Yes, ma'am.
So y triple dash we can find out from this one. That is, we have to find out d by dx of fx plus fy f. Okay, try to find out the derivative and tell me the answer. Yes. What is the answer? How to find out the derivative of this one? Yes, what is given to us? F is a function of two variable x and y. Okay, here x and y both are independent variable. So f is a function of two independent variable. Hence, we have used our partial derivative, right? So here also, if we are going to find out fx, that is a partial derivative of a function f, right? So if I want to evaluate the derivative of this one also, again I have to consider this as a uh, function of two variable itself, no, because y is treated as a constant, so it may be existing in your derivative with respect to x, correct? F originally is a function of x and y, and if you are going to find out a derivative with respect to x, it may involve some y, that may be it is y square, y cube, whatever may be function. Okay, so fx itself is also a function of two variable. If it is also a function of a two variable, then how to evaluate the derivative of fx and fy? Similar case will be for a fy. Since f is a function of a two independent variable, and if I want to find out a derivative, so fy is also uh, a function of a two variable, two independent variable. So if I want to find out a derivative of this, how to find out the derivative of this? I can write this as similarly with the help of a partial derivative, that is derivative of fx with respect to x and derivative of x with respect to x, plus next term what we can write is fx with respect to y and derivative of y with respect to x. Okay, plus, okay, plus we have to find out the derivative of this one also. Let me write down here as it is only d by dx of f into fy, right? So here we have to use a product rule for the derivative, but considering f and fy both are a function of a two independent variable, that means simultaneously we have to use a product rule for derivative as well as a partial derivative. Okay, are you getting this? Okay, this derivative of fx with respect to x, that I can write it as fxx, and derivative of fx with respect to y, fxy, and this I can write it as y dash, which y dash is nothing but your a function f of xy. Okay, plus let me evaluate the derivative of this one. For this, what we will do is the first one we will evaluate that f we will keep at it as it is, and then we will evaluate the derivative of fy, that is derivative of fy with respect to x, partial derivative, and derivative of x with respect to x, plus derivative of fy with respect to y and derivative of y with respect to x. Okay, similarly next we have to keep fy as it is, right? This one is in one bracket, and keeping fy in one bracket and evaluate the derivative, that is derivative of f with respect to x dx with respect to x, plus f with respect to y, derivative of y with respect to x. Okay, have you understood the steps? Hello, hello.
Yes,
Yes,
ma'am.
ma'am.
Okay, simply we are evaluating the partial derivative as well as the product rule. Okay, so let me write down the first terms as it is fxx plus fxy into y dash plus f as it is derivative of fy with respect to x, I can write it as fyx in plus dx with respect to x is 1. Next fyy y dash plus fy as it is. Okay, this f I have to multiply here also. Fy into f with respect to x with respect to x is 1, plus this fy I have to multiply inside. Okay, fy multiplying inside, this f with respect to y will be fy again. Y with respect to x is y dash. Now we know y dash is nothing but your function f. So let me put the value of y dash as function f. So what will be the result? Fxx plus fxy into f plus f into fyx. Now you have to tell me what will be the value of these two, whatever the underlying terms I have written. Okay, this y dash is nothing but f, so I can write this as f square also. Here is fx into fy plus, okay, what we can write next is fy square into the value of fy dash is f. Okay, yes, can anyone tell me what is the value of these two terms? Can I write it as 2 times? Because we know that fxy is nothing but your fyx. I hope you are knowing this. We have
Yes, ma'am.
studied this in the earlier. Fxx plus 2 times f into fxy. Simply I can write this as fxy plus this f into f square fyy, that is derivative of f with respect to y 2 times plus fx into fy plus fy square into f. Okay, so we have written up to this. This is what the third derivative we have found, y triple dash. Okay, in this way we can find out the next derivatives, and then after finding y dash, y double dash, y triple dash, we have to put it again in our equation 3 here, substituting x is equal to x naught, and then we will get the result. Okay, this is what the method we have to follow to solve any type of a differential equation by using the Taylor series. Okay, let us go for one example. You have to write with me from the Taylor series. Find y of 0.1 by using Taylor series method. Find y of 0.1. Correct up to 4 decimal places. Correct up to 4 decimal places with the initial condition y of 0 is equal to 1 and y dash is equal to x minus y square. Have you written the question? Find the solution by using Taylor series. That is, we have to find out y of 0.1. Correct up to 4 decimal places with the initial condition y of 0 is equal to 1, which means x naught is 0, y naught is 1, and the function y dash is nothing but your f of xy, right? From our method, y dash is f of xy, which is x minus y square. Okay, this is what the first example we will solve. Okay, what we have to do now, we have to write we have to expand the Taylor series in terms of x naught. What is your x naught? From this I can write value of x naught is 0 and y naught is 1. Okay, you have to write the thing expanding y of x in terms of a Taylor series at x is equal to x naught. Expanding y of x at x is equal to x naught. That is, we have to write down the Taylor series in terms of x naught. That is, y of x is equal to, what we can write is y of x naught plus x minus x naught into y naught dash plus x minus x naught square divided by 2 factorial y naught double dash plus so on. Now, as we are provided that we have to find out up to 4 decimal places, so we will find out up to 4 derivative. So the last term I can write it as x minus x naught raised to 4 divided by 4 factorial into y naught raised to 4, that is 4 derivative. And I will write here also x minus x naught cube divided by 3 factorial and derivative y naught y triple dash first we find out and put x is equal to x naught. Okay. As it is provided that we have to find out the answer correct up to 4 decimal places, then the method tells us that if you want to find out the answer correct up to 4 decimal places, then you should consider up to 4 derivatives. That means we have to consider the power of x, we have to consider up to 4. Okay. Now, what is the next job? We have to find out the derivatives. Okay, y dash, y double dash, y triple dash, y derivative y. So after finding all these derivatives, we have to put x is equal to x naught. What is our x naught in this case is 0. Okay, after finding all these, we will put in our equation. Okay, let me name it as some. Say this is our equation 1, which is given with some initial condition, this one. And this is what our equation 2, which we are going to use. First, we have to find out y naught. This is given to us, y naught dash, y naught double dash, y naught triple dash, and all. And then we will put. For that, first we will find out what is y dash. Y dash is nothing but your x minus y square. Okay. What will be y naught dash? That means we have to put x naught here. This will be x naught minus y naught square. Okay, what is your x naught given to us? 0. Minus y naught is 1. So we get the value of y naught dash is minus 1. Okay. Y naught dash we are getting as minus 1. Similarly, let us find out y double dash. If this is y dash, how to find out y double dash? Okay, how to find out y double dash? Derivative of this one is 1 minus 2y into y dash. Okay, derivative of this term y dash. Y dash is x minus y square. We have to evaluate the derivative of this. That is y double dash is equal to derivative of this term with respect to x is derivative of x with respect to x is 1. Derivative of y square is 2y. Derivative of y is y dash. Okay. Now we have to evaluate this one at x naught. Y naught double dash is 1 minus 2y naught and y naught dash. Okay, we know already what is the value of y naught dash from this equation. We can write this 1 minus 2 into y naught. What is the value of y naught from our given terms? Y of 0 is equal to 1. No, y of 0 is equal to 1, which means y naught is 1. Y naught dash just now we have calculated, it is minus 1. Okay. Here this is minus 1. I have written here. So we get it is as minus minus become plus. It is 1 plus 2, that is 3. Okay, let us go for the next one, that is y triple dash. We have to find out y triple dash, which is equal to, we have to find out the derivative of this one. For derivative of 1 will be 0 minus 2 times derivative of this term we have to evaluate by using the product rule. Okay. This y as it is, derivative y dash is y double dash plus y dash as it is, derivative y will be again y dash. Okay. So what will be the term? Minus 2 into y double dash into y plus y dash square. This is what your y triple dash. Minus 2. Okay, what is the value of y double dash? Just now we have found, since we have to find out derivative of y triple dash at x is equal to x naught. Okay, so I can write this as y naught double dash y naught plus y naught dash square, which is equal to minus 2 times y naught double dash. What is the value of y naught double dash is 3. Right, here from equation 2 we can say this is y naught double dash is 3 into what is the value of y naught? It is 1, that is a product, plus y naught dash square. What is the value of y naught dash? It is minus 1. You can see here this is minus 1. So minus 1 square will be 1. So finally we are getting it as 3 plus 1 is 4. 4 into 2 minus 8. Okay, we are getting this as y naught triple dash. Correct? Next we have to find out the fourth derivative of y, that is y fourth, which is equal to derivative of y triple dash. What is the value of y triple dash we have found? Let us see here. Y triple dash we have found is this term, minus 2 times y double dash into y plus y dash square. Okay, minus 2 as it is, y double dash into y plus y dash square. Okay, this minus 2 I can take outside. Taking minus 2 outside, we have to evaluate the derivative of this term. So y as it is, derivative of y double dash is y triple dash, plus next term y double dash as it is, derivative of y is y dash, plus 2 times y dash, derivative of y dash is y double dash. Are you getting how to find out the derivative?
Yes, ma'am.
Okay, so y naught raised to 4 minus 2. We have to find out the value of fourth derivative at a initial condition, that is y naught triple dash plus y naught double dash into y naught dash plus 2y naught dash into y naught double dash. Okay, now we are knowing all these values, just put up and tell me the answer. Y naught is 1 into y naught triple dash we have found is minus 8 plus y naught double dash. What is the value of y naught double dash we have found is 3 into y naught dash we have found it is minus 1 plus 2 times y naught dash is again minus 1. What is y naught double dash? It is 3. Okay, we are getting it is minus 2. This will be minus 8 minus 3 minus. Okay, finally what we get the value of this term is 34. Okay, correct? Is it 34?
Yes, ma'am.
Yes, ma'am.
Then up to this one, what we have to do? We have to substitute all this. This is small equation 1, that is y naught dash, y naught double dash. Next, we have to put this equation y naught triple dash and y naught raised to 4. All these 4 derivatives, we have to put it in our equation 1 using y naught dash, y naught double dash, y naught triple dash, y naught raised to 4, all these using in our equation 2, that is whatever the Taylor series we have written, expansion of a Taylor series we have done here. That means here in this equation we have to put all these values. Putting x is equal to x naught, what is the value of x naught in this case is 0. Okay, assuming all those value, I will write directly y of x is equal to 1 minus x plus 3 by 2. The 3 we have got the answer for y naught double dash minus 8. What is minus 8? It is y naught triple dash divided by 6, that is 3 factorial into x cube plus 34 we have got divided by 4 factorial, it will be 24 into x raised to 4. Okay, now what we need to find out, we are asked to find out the value at x is equal to 0.1, correct? So just put x is equal to 0.1 and tell me the answer firstly. Yes, what is the value of this term or whatever the equation we have written x is equal to 0.1. You have to find out up to 4 decimal places. Like up to 4 decimal places.
0.9138.
Okay. Everyone got the same answer? Yes, बाकीचे solve करतायत ना? Hello? At least those who are mentally present, you can put the answer on the chat box if you are really present.
Yes, ma'am.
Whatever the answer you got.
0.9138. 0.9138.
Yes,
Yes, ma'am.
ma'am. 0.913.
Okay, good. In this way, we have to solve the example by using our Taylor series. Okay, the similar example I will give, you have to solve just now here. Example, value of y dash is simply minus y. Okay, function f of xy is nothing but your minus y. And you find out the value of y of 0.1. Okay. What is given to us? X not similar. X naught is 0. Y naught is 1. Okay. Y of 0 is equal to this our equation. Solve it here only and tell me the answer fastly. Correct up to 4 decimal places. Yes. Whatever the method procedure we have followed just now, you have to follow the same procedure and you have to tell me the answer. Those who haven't written, for them I am scrolling this. What you have to do, first you have to find out y dash, then put x is equal to x naught. You will get y naught dash. Similarly, next you have to find out y double dash. Here in this example, it was a value of x also. But for current example, we are having y dash is equal to simply minus y. So this one example is easy to solve as compared to the example which we have solved just now. Okay, try to solve and tell me the answer. And for the homework, this same example you have to solve by using Euler's and Euler's modified method. For homework, the above example, this one, solve by using Euler's as well as solve using Euler's modified. Okay, you have to compare the answer because same equation we are solving by 3 different methods. First by Taylor series, then Euler's method and Euler's modified method. You have to compare the answer. In the next lecture, you have to tell me the what is the answer and what is the comparison where you get whether you are getting the correct answer. जे थोड़ा फार difference असेल, but you should tell me the answer. What is the answer by using Euler's method, Euler's modified, and next that you will tell just now by using Taylor series method. So in this way, if you solve this example, we will complete our fourth chapter. So we will remaining with only third chapter. Now, one may have a question that how to solve this example using Euler's and Euler's modified method. So at that time, you have to consider h is equal to 0.1. Only this one you need. Correct? Yes, what is the answer you got from Taylor series method?
Hello, ma'am.
What is the answer?
0.90483.
0.90.
483.
Okay. Correct up to 4 decimal places means you can answer this as 0.9048. Yes, anyone get the same answer?
Yes, ma'am.
Yes, any doubt for solving this? If no, we'll go for the next chapter. That is the last chapter we are remaining with numerical solutions of system of linear equations. Okay, what we have seen in this chapter is we have started with the Simpson's one third, 3/8 and trapezoidal rule. For that, what we have seen, first one, we have seen what is a general integration formula for numerical methods. And in that general integration formula, first we have put n equal to 1, that is a case 1, which we get the trapezoidal rule. And for n equal to 2, we get the case 2, that is a Simpson one third rule. Still, the homework is as it is. No one answered me what is the geometric interpretation behind Simpson one third and 3/8 rule. I told you what is the geometric interpretation for trapezoidal rule. And even I shared you the notes that how to find out the geometric interpretation of a Simpson one third and 3/8 rule. Okay. Let us see. After that, we have after completion of the numerical solutions of system of linear equation, that is the third unit if you complete, and then we will see what is the geometric interpretation. Okay. Up to then, you have to also search what is the geometric interpretation behind these concepts. And after that, we have seen these solutions of differential equation by using numerical method. The first one we have seen is Euler's method and the Euler's modified method, and now we have seen the Taylor series. Okay. Any doubt up to this? That is first, second, and fourth chapter. Now we are going to start the third unit. If time permits. If only 5 minutes are remaining. Yes, any doubt? Hello?
No, ma'am.
You're not having doubt? Just stop the lecture because it will, the methods are very lengthy for numerical solutions of system of linear. That means we are going to solve system of linear equation by using numerical solution. And also we are going to find out eigenvalues problem from numerical methods. So you can leave the meeting. Thank you. Remaining with the last chapter.